On this episode of Lykins Motorsports, we are going to take a look at a period correct Shelby Cobra 289 small block Ford build. So every so often I get requests to do, spot on period correct engine builds for restorations, or for guys who are real sticklers for the way things were back in the day. And those are some of my favorite builds because on the outside they look stock from the 1960s, 1970s, but on the inside they're filled with all kinds of modern goodies, modern pistons, modern piston ring packages, custom camshafts, all the good stuff that help make horsepower, ported heads, ported intake. So for this episode, we're going to take a look at a customer of mine. This build is, I think, almost 2 years old. 2 years old now. But he wanted a period correct 289 for his Shelby Cobra replica, and he was basing his replica off of a very early Cobra, very early 289 car. So we had to basically scour all of my Ford parts sources and all of eBay listings and that sort of thing to find all these numbers matching parts. And it took us a while because it's hard to find some of this stuff sometimes, and especially in trying to find it in good shape. But we were able to find an early 5-bolt 289 block and a crankshaft and some early C3, so that'd be a 1963 Ford 289 heads, along with a factory intake. So let's go through the way that we usually go through these builds, and we'll start with the engine block and make our way through to the entire engine. Okay, so the blocks are all treated the same way. They're baked and tumbled, and that gets rid of all the dirt and grease and paint and junk that's accumulated over decades of use. Then we treat them to our standard list of machining processes: boring and honing with torque plates, align honing the mains with ARP fasteners, and squaring the decks up. Sometimes this involves honing the lifter bores a little bit to make sure that they're on size. Then we use Durabond cam bearings, get those knocked in. On this particular build, we chose to use a performance bearing, which is a little wider bearing like you see here. Lifter bores are then checked for size. Morel and some other manufacturers generally want a specific clearance, generally around a thou and a half or so, and that varies on application and on lifter. For the bottom end, we used a factory 289 crankshaft along with some custom Racetech flat top pistons with a 1515 3mm ring pack. And we used some long rods on this. We used some scat I-beams in a 5/400 length, so that makes the piston a lot shorter, a lot lighter, at an 1.360" compression height, and with the 8cc flap top makes for a very lightweight rotating assembly. Then we make sure we know where we're at as far as how far the piston is in relation to the deck height. That helps to factor into our compression ratio calculations as well as our head gasket thicknesses. This setup come about 7 or 8 thousandths out of the hole. You can see the steel cam thrust plate there, along with a custom Lykins Motorsports billet core hydraulic roller camshaft. We get the mains and the rods all torqued up. Camshaft is in the high 220s for duration. A little under 600 lift, around the 590 mark on a 113 lobe separation angle. So for the cylinder heads, we used, as I mentioned earlier, some 1963 289 heads, and we were going to use a factory intake manifold. So in order to get the horsepower requirements that we were wanting above 300 horsepower. To do that with a factory intake and some other factory pieces, I sent the heads and intake manifold to Joe Crane. After the machine work was done, so we did bronze valve guides and fitted the heads with some Ferrea valves, 1725 on the intake and 1500 on the exhaust. So as the heads sat from factory, they flowed about 170 CFM at 600 lift. Joe was able to get another 20 CFM out of those. And the exhaust side was 115 at 600 lift. Joe increased that to 142. The intake manifold, stock, it flowed around 165 at 600 lift, and that was increased to 218. So between the cylinder head work and the intake manifold work, we were able to squeeze out a few more ponies than what these factory engines would have. Head was finally assembled with some pack valve springs, and finished those up with some AFR adjustable guide plates and some ARP rocker arm studs. So quality pieces, small diameter valve springs. Set these up at about 160 on the seat, about 380 open to match our hydraulic roller. And you always want to make sure that you have enough seat pressure for the application to keep the valves from floating. The intake manifold had to be treated to the same treatment as the block, baked and tumbled to get all the blue paint and everything off of it. And then I sent it down to Joe, and there's a shot of how much work he was going to do to the port openings. And like I said, it was really worthwhile to have the intake ported. So not only did we get a factory appearing engine, but we got a lot more performance than factory. For the oil pan and the oiling system, we went to Kevco and had them make a custom oil pan for us that looks factory appearing on the outside, but has some trays and some baffles on the inside to help with oil control. We matched that up with one of their custom pickups and with a Melling high pressure standard volume oil pump and an ARP shaft. So at this point it was time for some final assembly. You can see the Morel standard travel lifters put on there. You always want to put link bar lifters on before the heads go on a 289-302 engine. Any 8.2 deck small block Ford needs to have link bar lifters go on before the heads. That is a mistake that you will only make once. See the early model timing cover and the period correct harmonic balancer The balancer I found in really good shape. The elastomer was in really good shape. Did not have to have that rebuilt. With the head on and the lifters on, you can check piston to valve clearance. We had ample clearance because most of your small block Ford pistons, even when you tell them what size valves and everything you're going to use, they have to have a certain amount of valve relief to get the volume that you want. So have plenty of radial volume, plenty of depth volume on this one. Then with the heads on, we can finally get a coat of color after the primer. You see the Comp Cam's Ultra Gold full roller rocker arm, in a 1:6 ratio. ARP head bolts. So that's what I was saying about factory appearing on the outside, all kinds of nice goodies on the inside. Another shot of the adjustable guide plates that really make this kind of setup easy to manage. Going through, setting the preload on the lifters. There's that early timing cover again. You see the big freeze plug in the middle of the timing cover. A lot different than some of the later model covers. And then a shot of how our valve train geometry came out. A nice thin pattern across the valve stem near the center. Another shot of those AFR guide plates and ARP rocker arm studs. Then you see the early factory water pump. Bought that fully rebuilt from a water pump specialist so that everything looks period correct and it's actually an original piece. What really took some time on this engine was finding all the little parts and components for the front end dress, all the alternator brackets and that sort of thing. We scoured eBay and the internet for those parts. Everything had to be date coded correctly. You can see the distributor there, which is a original distributor that had been recurved, made to look new on the outside, and a Protronics conversion kit on the inside. Factory reproduction plug wires. And we went to PowerMaster for a period correct generator. So I say generator tongue in cheek. It looks like a generator on the outside, looks like a factory Ford generator, but on the inside it has alternator guts, so you get the best of both worlds. And then you see some factory pulleys that have been added there. And then after assembly, we are ready for Dino Time. And again, we went to Delmir's Racing Engines in Buffalo, Kentucky. It's where I dyno 99% of my engines. Got that on the pump, and you see there the factory Le Mans carburetor that was very carefully and well done by Drew Projednik out of Georgia. Everything looks spot on for that carburetor. Here's the dyno results. 325 horsepower at 6,200 RPM and about 314 pound-feet of torque. So that was just a sweetheart of a little engine, and enjoyed doing this one very much. And that carburetor looks awfully nice there. That is a factory carburetor that was completely refurbished. We used a 1-inch phenolic spacer, so it looks period correct, but we still get a little bit of help from a carburetor spacer on top of that fairly short and low intake manifold. So just a sweetheart of a build, and as far as I know, my customer has not received his car yet. A lot of red tape with bringing cars in out of the country, and things just take a very long time. So maybe we can get an update from him once the engine is in the car and all buttoned up. Thank you guys very much for sticking with me on this one. I like doing these one and done type videos to kind of show the whole thing in one video instead of spreading it out in 4 or 5. I'll still do both, but it's nice to do a recap of the entire build from every now and again. Thank you for subscribing to the channel. If you haven't, please do that now so that you don't miss out on further videos coming down the pipe. Got lots of Ford stuff to do, lots of new things to show. You don't want to miss out on that. Hope you guys are having a good week, and I'll talk to you soon.